Alright, today we're going to do 3.6 homework part 1. Starts on page 208, numbers 1, 2 to 32 even. Alright, so there's 3 steps you have to follow. Step 1 says you have to isolate the radical. That means get the radical all by itself. So isolate means get the radical by itself. So radical by itself. Alright. Raise both sides to the nth power, and whatever nth power that is, it's the number inside the check mark. So if I have a square root, I'm going to square root both sides. If I have a cube root, I'm going to cube both sides. If I have a fourth root, I'm going to take both sides to the fourth power. Step 3 says you solve the remaining equation. Alright. Now remember, because of this thing called an extraneous solution, you have to check every answer. In part 1, you're not going to have any problems that won't work, but you need to know how to plug it into your calculator so when you start part 2, you're confident you can do that step. All right, so to get full credit, you have to check every answer. All right, number 1 says when you solve an equation algebraically, an apparent solution that must be rejected because it does not satisfy the original equation is called an extraneous solution. So we talked about that the other day. That means you do all the math correct, but when you check your work, it doesn't work. It's like a false positive. So in that case, we call that extraneous solution, and we just throw that solution out. It does not count. Okay? All right, number 2 says a student was asked to solve this equation, the square root of 3x minus 1 minus 9x minus 5 equals 0. While trying to isolate x, he gave up in frustration because he tried to square each side first. What could the student have done to avoid the situation? So and this is what we're going to talk about today in class, or tomorrow in class, when there are 2 radicals, they must be on opposite sides. Before squaring. So the first thing he should have done is he should have added the square root of 9x minus 5 to both sides. So he would have got the square root of 3x minus 1 equals positive 9x minus 5. Now when he squares both sides, he could square both sides, and both the radicals will disappear at the same time, and it becomes a pretty easy multi-step equation. And that's it. Alright, number 4, we have the square root of 3x plus 10 equals 8. Now the radical is already isolated, so the radical is already isolated. And what that means is there's no one out of jail on the left side. So nobody's out of jail. I like to think of it using Pemdas Backwards, and I like to pretend there's parentheses in there. So there is no subtraction. The addition is inside the parentheses. There's no division. The multiplication also inside the parentheses. So I have to get rid of the radical. How do I get rid of the radical? I use an exponent. So the first thing I do is I square both sides. If you're following the book's method, the radical is already isolated. So then you're going to square both sides, which means raising both sides at the same power. And because there's a little 2 there, that's why I picked this 2. They cancel. I'm left with 3x plus 10 equals 64. Minus 10 from both sides, minus 10 from both sides. 3x equals 54. Now I have to undo the multiplication. I divide by 3, I get x is equal to 18. Now you're not done here. If you don't check your work, you're not going to get any credit. So you have to plug 18 in. So I rewrite the whole thing. 3 times 18 plus 10 equals 8. I don't know if that's true yet. I do 3 times 18, that's 54, plus 10 is 64. So yes, the square root of 64 does equal 8. It does work out, so we're good to go. And that's enough for that problem. Alright, so number 6, the radical is not isolated because minus 2/3 is out of jail. Like I said, I like to use PEMDAS in reverse and pretend there's parentheses right there. So the first thing I do is I see that subtraction. That's why I add 2/3 of both sides. So either way you look at it, you have to get rid of the 2/3. So that's why you do it by addition. So you have the square root of 2x equals positive 2/3. There's no addition, there's no division, there's multiplication, but it's inside the parentheses. So now I have to use an exponent to get rid of the radical. So I square both sides, because there's a little 2 there, and those cancel. So I have 2x equals 4/9, because you got to square the top and the bottom. Now I divide by 2. I get x is equal to 2/9. Last thing I have to do is check my work. So I put it in the original problem. I say 2 times 2/9 minus 2/3. Does that equal 0? It does. If you plug in your calculator, you do get 0. Make sure if you get domain error or something, it's likely that you forgot to close the parentheses after that bar ends. That's the mistake you're probably making. So that's it for 6. All right, number 8. We have 8 times the square root of 10x minus 7. The radical is not isolated. All right, you have they're out of jail, and so is that 8. So you have to get rid of them first. Like I said, I like to just use Pemdas backwards. And that's how I usually do it. I pretend that's parentheses, because it is parentheses. If you go to plug in your calculator, it's going to be in parentheses, so it's implied there. So I see, look, subtraction. There's subtraction. That's not inside the parentheses. I had 7 on both sides. I have 8 square root of 10x equals 16. Now, there is no addition. There's no division. There's multiplication. That's why I have to divide by 8 on both sides. I get the square root of 10x equals 2. Now, I have to get rid of the radical. How do I get rid of the radical? I use an exponent. So the first thing I have to do is I have to square both sides, because it's a square root. I get 10x is equal to 4. Now I divide by 10. Divide by 10. I get x is equal to 2/5. Now I'm going to plug that in. So I say 8 times the square root of 10 times 2/5 minus 7. Does that equal 9? It does, because I plug it in my calculator, it works out, so we're good to go. So x equal to 2/5 is a good answer. And that's it for number 8. All right, 10. We have negative 4 square root of x minus 6 equals negative 20. All right, I'm going to divide both sides by negative 4. I get the square root of x minus 6 equals positive 5. I square both sides, I get x is equal to 20, I get x minus 6 equals 25. I add 6 to both sides, I get x is equal to 31. Alright, plug it in. I get negative 4 square root of 31 minus 6 equal to negative 20. And it works. Okay, so that's it for 10. Alright, 12. We have the square root of 8x plus 3 equals 3. This radical is already isolated, so I square both sides to start. So I get 8x plus 3 equals 9. Subtract 3 from both sides. I get 8x is equal to 6. Divide by 8. I get x is equal to positive 3/4. Now we plug it in to check our work. So I say square root of 8 times 3/4 plus 3. Does that equal 3? It does. So we're good with number 12. Just going to continue to move on. Alright, 14 through 20 is the exact same concept, but now we're using cube roots, which means we're going to change our exponent. We're not going to be able to square both sides. We have to cube both sides. So once again, I go Pemdas backwards. And you guys remember, technically x minus 16 is in parentheses. So I don't see any, I see subtraction, but it's inside the parentheses. There's no addition, there's no division, there's no multiplication. And technically there's a little check mark, so I have to get rid of that first using the exponent. So the first thing I do is I cube both sides. I end up with x minus 16 equals 8. I add 16 to both sides, because now I can undo the subtraction because the parentheses are gone or the radical is gone. I get x is equal to 24. I have to check my work still. Just because it's a cube root doesn't mean you don't have to check your work. You still have to check it. Now remember, when you use your calculator, you're going to hit second, and then you're going to hit the caret button because it has x check mark on it. So we're going to say 24 minus 16, and you're going to add those in parentheses when you use that. So if you're using the calculator, you're going to add the parentheses in there. Is that equal to 2? It is. So that's a good answer. And that's it for 14. Alright, so number 16, I have a cube root of 16x, but remember that's out of jail and that's out of jail, so I have to get rid of those things first. Like I said, I like to use Pemdas Backwards because I just think it's a little bit easier for me to see. That's in parentheses. I see subtraction. That's why I add 7 to both sides first. So I get 3 cube root of 16x equals 24. Subtraction's gone. There's no addition, there's no division, there's multiplication. So I have to divide by 3 first, because that means 3 times the cube root of 16x. I get the cube root of 16x equals 8. Now I have to cube both sides. I get 16x equals 512. So I divide by 16, get x is equal to 32. So now I'm going to plug it in and check my work. So I'm going to say 3 cube root of 16 times 32 minus 7 equals 17. And it works. And that's it for 16. Alright, so 18, I have the cube root of 4x plus 5 equals 1/2. Now, there is no subtraction. Remember, those are in parentheses. So the addition is inside the parentheses. There's no division. There's multiplication is in the parentheses. So I have to get rid of the check mark now because the radical is already isolated. So the first thing I do is cube both sides. I get 4x plus 5 equals, cube the bottom, cube the top, you get 1/8. Now I'm going to multiply everything by 8. Because if I do that, it's going to make the radical go away, or the fraction go away until the end, because most of you guys don't like fractions. So you're going to get a fraction answer, but if you multiply by 8 to start, you will not have any fraction show up to the last step. Plus, it makes it a little bit easier to keep it in improper fraction form. So I subtract 40 from both sides, because that's undoing that addition that was in the parentheses. It's gone. I get 32x equals minus 39. Now I divide by 32, divide by 32. I get x equals minus 32 over, minus 39 over 32. So I plug it in. I say the cube root of 4 times negative 39 over 32 plus 5. Remember, that's all in the bar, so when I plug it in my calculator, it's all going to be in the bar. It's supposed to equal 1/2, and it does. So that means this is a good answer. And that's it for 18. Alright, so number 20, I'm once again going to do Pemdas Backwards. And I see subtraction. Notice, remember, 4x plus 2 is inside the radical, so it's like parentheses. Or just imagine that it's in jail and you have to get rid of the minus 6 because that's out of jail. So before you do anything, you have to add 6 to both sides. You get the cube root of 4x plus 2 equals negative 4. Alright? Remember, those are in jail, or in parentheses. So there's no addition because it's inside the parentheses. There's no division. There's multiplication, but it's inside the parentheses. So you have to get rid of the radical first. And how do I get rid of a cube root? I cube both sides. So I'm left with 4x plus 2 equals minus 64. I subtract 2 from both sides, subtract 2 from both sides. I get 4x equals minus 66. Divide by 4, divide by 4. I get x is equal to minus 66 over 4, which turns into minus 33 over 4. Now, I'm going to plug that into my and that should be minus 33 over 2. I don't know why I forgot to put the 2 there, because I divided both the top and the bottom by 2. So negative 66 over 4 is equivalent to minus 33 over 2, or 16.5, whatever you have. So I'm going to plug this in and see what happens. I say the cube root of 4 times negative 33 over 2 plus 2, close the bar. All right, so close the parentheses if you're plugging in your calculator. Minus 6, does that equal negative 10? It works. And that's it for 20. Alrighty, so we need to make a true statement for the cube root of ax plus b is equal to c. I can pick whatever I want, so I get to choose whatever I want for a, b, and c. X has to equal negative 3. So right away when I start this, I have the cube root of something times negative 3 plus something that's going to give me c. So my rule, my step 1, is going to be pick a and b that make a perfect cube, because I don't want anything messy for c. If it's not a perfect cube here, c is going to be messy. So I'm going to say pick a and c that make a perfect cube. So I'm going to pick a first. I'm going to pick a to be 1. So I'm saying a is going to be equal to 1. I know that 1 times negative 3 is negative 3. I know that negative 8 is a perfect cube. So I'm going to pick b to be negative 5. So I have the cube root of 1 times negative 3 plus negative 5 is equal to c. Step 2, evaluate radical for c. So I have 1 times negative 3 is negative 3 plus negative 5 is negative 8. The cube root of negative 8 is going to be my c. Well, the cube root of negative 8 is 2. So negative 2 is c. So there's my c, there's my b, and there's my a. And I made a true statement. You could have any sorts of different values for a, b, and c. This is just one option. There's an infinite amount of correct options here. Okay? And that's it for 22. Alright, so 24 through 30 are going to have fraction exponents. And fraction exponents are just a fancy way to write radicals. So you have two options. You can use this formula here, and then you just do what we did last time. Or you can raise it to a reciprocal, remember, flip exponent. And this step 2 is always going to be faster. So it might be easier to get used to step 2, but you can always use step 1. In number 24, I'm going to show both options, and then from then on, I'm going to do option 2. All right, so that's it. All right, so number 24, we have 1/2 x to the 5/2 equals 16. First thing you need to point out is 1/2 is not with the x to the 5/2. It's 1/2 times x to the 5/2. All right, that's going to be important in a little bit. So I do my Pemdas backwards. There is no subtraction, there's no addition, there's no division, multiplication. That's why I divide by 1/2 first. If you don't want to divide by 1/2, you can multiply by 2 because you're multiplying by the reciprocal. I get x to the 5/2 equals 32. Now, option 1, so this is option 1, says you're going to use that as a, that as m, and that as n. And you make this the square root of x to the 5th equals 32. Then you square both sides, you get x to the 5th equals 1024. You take both sides to the 5th root, you get x is equal to 4. That's a good option, okay? But this is faster. I say I have x to the 5/2. I just raise it. I raise both sides to the 2/5 because the 2/5 will cancel. And as long as I do it to both sides, I'm allowed to do that. I get x is equal to 4. Final step, we have to check that works. So we say 1/2 times 32, 4 to the 5/2, that equals 16. It does. So 24x equals 4 is a good answer. And that's it for 24. Alright, number 26, we have 8x. Notice, 8x is with the exponent. So you cannot get rid of that x. You cannot get rid of that 8 until the exponent's gone. So, but if you use Pemdas Backwards, it would actually tell you that right away, because you see there is no subtraction, there's addition, so I minus 44 first. I get 8x to the 4/3. Please don't lose those parentheses, they're really important right now. Equal 256. So there's no more addition, there's no more division, there's multiplication, but it's in the parentheses, so you have to get rid of the exponent. You could use a, m, and n, but I'm just going to take both sides to the 3/4 because that's the reciprocal. Notice the 3/4 doesn't affect the 8 because it cancels before it has a chance. That was 256, by the way. So I have 3/4. 256 to the 3/4 is 8x equals 64. So then, because that's even, you have to have plus or minus there. So because that's even, that bottom number was even that we raised it to, it has to be plus or minus. And then divide by 8, I get x is equal to plus or minus 8. Check your work. So you say 8 times 8 to the 4/3 plus 44 equals 300. It works. Check negative 8. Negative 8 might say domain error, depends on what calculator you're using, but it does work too. So when you check negative 8, it does work, even though it might say domain error in your calculator. And there's another way to plug it in. If you ask me about it, I'll show you. Alrighty, 28. Once again, I do my Pemdas Backwards symbol. I see subtraction, but it's inside the parentheses. I also see subtraction outside the parentheses. That's why I add 73 first. I don't care about that x minus 5 yet. I can't do anything with it. So I have x minus 5 to the 5/3 equals 243. Now, only thing I can see next is an exponent, so I have to raise it both sides to the 3/5. So when I raise both sides to the 3/5, 243 caret 3abc5 becomes 27. So this turns into 27. Those cancel, so you're just left with x minus 5. Now I add 5 to both sides. I get x is equal to 32. Last thing I do is just check my work. So I say in parentheses 32 minus 5 to 5/3 minus 73. Does that equal 170? Check it. It does. So my final answer for 28 is just 32. And that's it. Moving on to 30. Alright, so 30, I'm going to use Pemdas Backwards. I'm going to add 19 to both sides, so I'm going to add 19, add 19. I get 5x is equal to 32 plus 19 is 51. I divide both sides by 5. I get x is equal to 10 1/5. Alright? And that's my final answer for 30. Alright, 32, the book made a mistake, so I'm not even going to look at the book's work right away. First, I'm going to focus on, I'm just going to do the problem all by itself. So I write my Pemdas Backwards. I see there's addition, so I subtract 2 from both sides. I get the cube root of x equals 2. I cube both sides. I get x equals 8. I plug it in. Does the cube root of 8 plus 2 equal 4? It works. So now I compare what the book did. The book cubed before isolating the radical. So they cubed first when they shouldn't have. And that's what they did wrong. And that finishes this assignment. Alright, so that was 3.6 homework part 1, page 208, 1, 2 to 32. There are 2 mistakes on purpose. Hopefully there's no more than that. So make sure you check your work.